Error is d, and time needed to cover the distance is 1 second. Now you can see that the beam of light in stationary clock, it is traveling exactly the distance d. Watch carefully that the beam of light in moving clock is traveling more distance, and it will show slower time as compared to stationary clock. So, what is 1 second for the stationary clock is not 1 second for the moving clock, and this is time dilation. So, the faster you will travel, slower the time will pass for you. Whatever, now we'll discuss about length contraction. The fact is, time doesn't actually dilate enough to keep the speed of light constant. Something else happens in its length contraction. So, it's not just time that's relative, it's length as well. New boy in the 2 clock. Now, what happens is, when it's moving in very high speed, the object's length contracts. Here, in the case of clock in motion, the distance between two mirrors is smaller than we thought. So, the distance has to travel is actually smaller than we think. In conclusion, time dilation and length contraction work together to ensure the speed of light remains constant. On the other hand, theory of general relativity gives us idea about gravitational time dilation, precession, light deflection, frame dragging, metric expansion of space. Basically, he explained gravity. This can be visualized as through an example of trampoline. That because of the mass of the sun, a simple path is created, and all the planets follows the simplest path, like it happens in trampoline. But think that the trampoline analog you normally see on TV is a 2D plane used for visualize this, but it's actually in 3D. It looks more like this graphic. To be much more accurate, it's like this. Now, this is much more difficult to visualize or animate, and that's why popular TV shows or explanation ignores this, but it's more accurate. There have been a lot of experiments, and in all experiments, Einstein's theory has repeatedly been proven absolutely right. One of the most famous experiments is Half-Keating experiment. The Half-Keating experiment was a test of the theory of relativity. To be fair, they were looking at both time dilation due to motion and gravitational time dilation. In October 1971, they took 4 cesium atomic clocks aboard commercial airliners. They flew twice around the world, first eastward, then westward. Other clocks remained at the U.S. Naval Observatory. When reunited, the 3 sets of clocks